Hello everyone, graphs are very useful structure in programming because often computer science problems can be represented as a graph and solved using one of its techniques. Even though the field of graph theory is deep and fascinating, this video includes finding the shortest path. There are several well-known algorithms for doing so. This video will be about the implementation of Dijkstra's algorithm. The problem of finding the shortest path has many applications. As we know, in a telephone network, each line has a bandwidth. The bandwidth of the transmission line is the highest frequency that line can support. Generally, if the frequency of the signal is higher in a certain line, the signal is reduced by that line. Bandwidth represents the amount of information that can be transmitted by the line. If you imagine a city to be graph, the vertices represent the switching stations, and the edges represent the transmission lines, and the weight of the edge represents the bandwidth. So as we can see, it can fall into the category of shortest distance problem, for which the Dijkstra's algorithm can be used. Given a graph with non-negative weights on the edges, a well-known algorithm for finding the shortest path between two vertices was discovered by Edgar Dijkstra, a Dutch computer scientist. In order to find the shortest path from vertex S to vertex V, Dijkstra's algorithm finds the shortest path from S to all vertices. So Dijkstra's algorithm is known as a single source shortest path algorithm. The algorithm uses cos V to store the cost of shortest path from vertex V to the source vertex S. Cos S is 0. Initially assign infinity to cos V for all other vertices. The algorithm rapidly finds the vertex Y in Vt with the smallest cost y and moves y to t. The algorithm starts by setting cos S to 0 in line 4, sets cos V to infinity for all other vertices. It then continuously adds the vertex say y from Vt into t with the smallest cos y in lines 7 to 8, as shown in figure A. Let me illustrate Dijkstra's algorithm using the graph in figure A. Suppose the source vertex is 1. Therefore, cos 1 is 0 and the costs for all the vertices are initially infinity, as shown in B. We use the parent 1 to denote the parent of 1 in the path. For convenience, set the parent of the source node to -1. Initially, set t is empty. The algorithm selects the vertex with the smallest cost. In this case, the vertex is 1. The algorithm adds 1 to t, as shown in second figure A. Afterwards, it adjusts the cost for each vertex adjacent to 1. The cost for vertices 2, 0, 6 and 3, their parents are now updated, as shown in B. Now T contains 1, 2, 0, 6, 3. Vertex 5 is 1 in Vt with the smallest cost, so add 5 to T, as shown in figure 7, and update the cost and the parent for vertices in Vt and adjacent to 5 if applicable. This is the implementation of Dijkstra's algorithm. Also, adjacency matrix representation of graphs is used. This algorithm can also be implemented using adjacency list to improve its efficiency. We create a two-dimensional array of size 7 to 7 for adjacency matrix to represent a graph, and we create an array to track selected vertex. Select will become true, otherwise false. Distance of self loop is 0. We update the distance between neighboring vertex and the source vertex and find the minimum distance. Now let's talk about the pros and the cons. The advantages is that mentioned algorithm. First of all, we'll find the smallest amount of weight passed to all or any permanently labeled nodes. Secondly, we don't need a replacement diagram for every path. And the last one, Dijkstra's algorithm has a time complexity of n square, so it's efficient enough to use for relatively large problems. The disadvantages include that this method it does a blind search, thereby consuming tons of our time, wasting necessary resources. Another disadvantage is that it's not applicable for a graph with negative edges. This results in acyclic graphs and most frequently cannot obtain the proper shortest path. In conclusion, I want to say that the world of graphs in computer science is huge. Practicing skills for solving algorithm problems, especially algorithms on finding the shortest path, will help us to successfully pass technical interviews. Thank you for your attention.